In this video, we are going to discuss this problem which says that find the maximum power that can be delivered to the resistor R. So, the resistor R is given here, the value is not given, we have to find the maximum power that can be delivered here. So, for maximum power, what we need to do? So, we need to find such a resistance. So, we need to find such a resistance whose value will be equals to equivalent resistance of the circuit, that will be equals to RTH. Okay. And to find the maximum power, we need to calculate the VTH also. So, what we have to do is the total circuit, I need to represent it as a combination of a voltage source and a current and a resistance. So, where VTH is here and your RTH will be here and the resistance R will be here. So, we have to replace the circuit like this and the resistance value will be equals to RTH for maximum power transfer. And what is the maximum power will be transformed? The formula is VTH square divided by 4 into RTH or 4 into R. So, first we have to find the VTH and RTH. So, let us do that. So, to do that, what is the process? We need to remove this R resistance and then we have to calculate the VTH and RTH both. So, if I remove the R resistance, then what will be the circuit will looking like? So, let us see that. So, this resistance is here and from this point the resistance is connected here and one voltage source is here, polarity is given like plus minus, and here this part will be your open circuit where we are going to calculate the RTH value and the VTH value. So, I have removed this R and here one resistance is there and then one current source is there whose value is given as 6 ampere and the resistance is given as 5. Okay. Then this resistance value is 5, here it is given as 2, one voltage source is here and the voltage source value is given as 25 volts. Okay. We have to calculate the VTH and RTH at these two terminals. Okay. Let us be these two terminals and A and B. So, we will be first we will calculate VTH, then we will calculate what is the value of your RTH. So, before calculating, so for easy calculation what I can do, so this current source and this resistance I can make them source conversion and I make it a voltage source series with a resistance. So, for that if I do, then what will be? So, we are doing the source conversion here. So, if I do the source conversion, okay. So, how the circuit will be now? So, this is circuit. So, what I am doing here is this particular branch I am doing in line with the circuit. Okay. So, plus minus this value is given as 10 volt. So, 10 volt and here after converting to a voltage source, so the direction will be like this. So, here current direction is like this, that means the negative terminal will be here and the positive terminal will be here and this value will be 6 into 5, that is equals to 30 volt. So, this current into the resistance, that is 30 volt and the resistance value in series, so that is 5. This resistance is given as 5 and this resistance is 2 and the voltage source is here, the value is 25 volts and the terminals, where are the terminals? So, here and here. So, we have to calculate the VTH across this terminal. Okay. Now, let us calculate how to calculate. So, to calculate this VTH, if I can find what is the total voltage drop across this area, then I can find what is the VTH. VTH is nothing but voltage drop across this 2 ohm and the 10 volt, combination of that will give me the VTH. So, to calculate that, what I can do? So, I can take the mesh analysis here. So, I will take the current as I here. So, if I find the current I, then 2 into the current will give me the voltage drop here and addition of these two voltage will give me the what is the total amount of voltage available there. Okay. So, now to calculate the VTH, I will write the mesh analysis equation. So, that is 25. So, this 25 minus 5I minus 2I. Here you see this 10 volt terminals you see. So, here negative is there, here positive is there. So, that is why it will be taken as plus 10 Again here negative terminal here, positive here, so this will be taken as plus 30 minus 5i is equals to 0. So if I solve this, so it will be, so 5 to 7 and then 5, so minus 12i plus so 25 plus 10 35 plus 30 is 65 is equals to 0. So that implies what is the value of your I1 now? So I1 will be equals to 65 divided by 12. So that value is how much? 65 divided by 12. So that is equals to 5.41 amperes. Okay, now this value we got 5.41. So what will be VTH value now? So see here, the current is flowing in this direction. Okay, so for that what will be the voltage? So here it will be negative, here that will be positive, then only we will get the VTH like this. So your VTH is equals to how much? So minus 2 into this current is 2.41 plus 10. Okay, so that will be equals to into 2, so 10.8 minus 10.8 plus 10, so that is equals to minus 0.8. so the voltage is coming as minus 0.8. so that means this VTH value is minus 0.8. so that means the polarity will be opposite way. Okay, next is what we have to do? So we have to find the RTH. For RTH, what to do? We need to remove all the sources in the circuit and replace the voltage source as a short circuit and the current source as a open circuit. In this case, we don't have any current source. Initially it was there, but we have converted that to a voltage source. So we will be going with that circuit. So now if I redraw the circuit, so here the 5 ohm resistance is there, here the voltage source was there, so it will be short circuited. Okay, and here one resistance is there, here one voltage source are there, it will be short circuited. Again one voltage source is there, it will be short circuited. Another resistance is here. So this will be my circuit now. The resistance value is 5, 2 and 5. We have to find what is the equivalent resistance here, RTH. Okay, so how to find that? So in this circuit you can see now the circuit actually look like 5, 2 and these 3 resistance are in series, but it is not the case. If you find the resistance at this 2 point, then what will happen? This 5 and this 5 they will be in series, because you can see they are connected end to end. So this is in series and that will be in parallel with 2. So if I redraw the circuit, so it will be here 2 ohm resistance is there and one resistance will be here. So this value will be how much? 5 and 5 in series, so 10, and we have to calculate what is the RTH value here. Okay, so what is the RTH value now? So RTH will be equals to 10 parallel 2, so that is equals to 20 divided by 12. So 20 divided by 12, so this is equals to 1.66 ohms. Now the total circuit I can represent as a voltage source whose values VTH is equals to, we got 0.8 volt, and the resistance here, resistance we got 1.66 ohms, and then we will connect the R here, this R, this which are this R value that we have removed from the circuit. So this R. So in this circuit now what is the, when the maximum power will be there? Maximum power will be there when this R value is equals to RTH, and that is equals to 1.66 ohms, and the maximum power will be equals to VTH square divided by your RTH, or 1.66, sorry 4 RTH. I have written it 4 RTH. Okay. So that is equals to VTH value is how much? 0.8 square divided by 4 into 1.66. Okay. So let us calculate that. So VTH 0.8 square divided by 4 divided by 1.66. So that is equals to 0.09 watt. So, this is the maximum power that can be delivered to the load or to the R resistance. So, this is how you can calculate the maximum power, and this is the process. So, generally where will be the difficulty? So, till now we are already always considering a circuit like this, and here you have to find the RTH. So, general convention was look into the circuit in the horizontal manner, but here the circuit you have to look it in the vertical manner. So, you may get confusion. So, nothing to confuse here. So, you imagine this circuit in the vertical manner, I can do it, or else if you get confusion. So, what you can do, this circuit you can redraw as. So, here your 2 ohm is there, and this point you have to calculate the R equivalent here, and here what is there, the 5 ohm is connected, and here 1.5 is connected. So, now you can calculate it easily. So, if you find difficulty looking the circuit in the vertical manner. So, this is how you can calculate the maximum power, and in the next video we will be discussing with some more problems. If you have any doubt, then you can put in the comment, I will try to answer. Thank you.